Okay, so in the last video we were thinking about integer arithmetic. Now we're going to think about doing some maths with real numbers, with doubles. Okay, so now since last time I've added mass and velocity. And so we're going to do a couple of things. First thing we're going to do is, well, we'll do it down here. What we're going to do is, first of all, calculate energy, kinetic energy. So energy is equal to half mv squared, 0.5, times mass, times, I'm just going to do velocity times velocity to get v squared. So, now I should add a statement to print out the mass and velocity, so I can do that just here. So, and now we want to print out new energy. So let's have a statement here that says calculated kinetic energy equal to %G. So that should run. Okay, so here's some new stuff here. Mass and velocity. So velocity squared is going to be 6.25. So mass times velocity squared is going to be 62.5, and it's a half mv squared, so we divide 62.5, we get this energy of 31.25 joules if the mass is 10 kilograms and the velocity is 2.5 meters per second. So that's sort of a case of using a multiplication. Now it's all it's all straightforward. Let's take another example. Let's say that the kinetic energy, let's set kinetic energy up as 50, and the velocity, we're going to say that that's equal to 7. So if kinetic energy is 50 joules, velocity is 7 meters per second. We're going to turn this equation around and calculate the mass. We'll just comment this one out. I might actually just copy it and paste it. And now what we're going to say is the mass is equal to 2 times the energy, or 2.0 times the energy divided by velocity squared. Now I wanted to give this example because it's an example of using division, and we saw for integers we get a number and a remainder when we do division, but of course when we do a division with real numbers, if you have 5 divided by 2 is just 2.5, we don't have to worry about it being 2 remainder 1 or anything like that. So now we've calculated the mass. Add in there. And let's run that and see what happens. So if the energy is 50 kilograms, and sorry, if the energy is 50 joules and the velocity is 7 meters per second, well, 7 meters per second squared is 49, and so the energy is approximately equal to the velocity squared, And so if looking at this equation here, the energy is 50 and the velocity squared is 49, it's about 50, then we expect mass to be about 2. We expect this bit in the middle to be 1. If that's a half, then mass is about 2. So this looks like the right answer coming out. And it's a if you calculate that number, it's going to come out to with loads and loads of decimal places, but the computer will calculate it to a certain number of decimal places, and then when you do %g, it prints out about 6 of them or something. So